All right, guys, here we go. All right, guys, here we go. So you guys know how to plot points already, right? So the idea behind this is we're going to start by plotting points, and then we're going to see if we can figure out what that sketch is or what that curve is. Does that make sense? So usually remember how you plot points. It's r comma theta, but remember how I told you that we do the theta first and then best of the theta, then we do the r? Okay, so here we go. I'm gonna make a table, theta and r. And I'm basing it off of this equation. And these are the tabs of the possible graphs that I can have. We're still okay? Nothing crazy? All right, so check it out. I'm gonna start at 0 degrees. Or 0 radians. So if I plug in a 0 in here to negative 2 sine theta, sine of 0 is 0, and 0 times anything is? So I start at 0, point. Remember, that's actually this. This is the r, and this is the theta. Are we okay so far? Nothing crazy, right? All right, next. By the way, just in case, this is pi over 12. This is 2 pi over 12, which is pi over 6. Bless you. This is 3 pi over 12, which is pi over 4. This is 4 pi over 12, which is pi over 3. And this is 5 pi over 12. And this is pi over 2. They go by 1/12 pi. Are we still okay? No? Okay. Here we go. I'm going to go to pi over 6. What is sine of pi over 6? I don't know, 1/2. Well, yeah, 1 over 2, 1/2. And what is half of negative 2? Negative 1. I'm going to go to, let's see, pi over 4 is not a perfect number. Pi over 3 is not a perfect, no, that's fine for now. Let's go to pi over 4. Sine of pi over 4 is square root of 2 over 2. And then when I multiply by negative 2, the 2's cancel out, and you get negative square root of 2. And then at pi over 3, sine of pi over 3 is square root of 3 over 2 times negative 2 is negative square root of 3. Are we still okay, guys? Don't worry. We're going to plot it in a little bit. And then finally, pi over 2. Pi over 2 is, sine of pi over 2 is 1. And 1 times negative 2? Negative 2. All right, let's plot it. It doesn't have to be perfect. So negative square root of 2 is, let's see what it is. Negative square root of 2 is that number, and negative square root of 3 is that number. Negative 1.414 and negative 1.732. Negative 1.414 and negative 1. I already forgot it. Short-term memory. 732. 732. Okay. I'm going to go slow. This point here, remember, it's r comma theta. Negative 1 comma pi over 6. So go to pi over 6 first. Here it is, the ray pi over 6. It's this one right here. I'm using it with my laser. And I'm going to go in reverse. Negative 1. So if I go in reverse negative 1, I'm right here. We still okay? Next one, pi over 4, negative 1.41. So here's pi over 4. This is my pi over 4. And I'm going to go in reverse, so I'm going to be in quadrant 3. So negative 1.41, I'm going to be like right here. Pi over 3. So I'm looking at this guy right here. And I'm going to go in reverse. I'm going to be back in quadrant 3. So I'm going to be at 1.7, negative 1.7. So let's see, it's like right here. And then pi over 2, so that's a positive y-axis. And I'm going in reverse. I'm going negative 2, so I'm going to be like right here. Do you see a pattern? Let's connect it. If I were to keep going, what shape do you think would happen? Yeah. It's supposed to be symmetric on the y-axis, but there it is. And there it is, guys. You did your first one. You did your first polar curve without a calculator. Cool or not cool? Now, hot chop, can I use a calculator? Well, I guess, but you're not always going to have a calculator. So everyone follow with me. Do you guys have a calculator? Push the mode button. Do you see where it says function? Go to polar. And later on this year, we're going to go to parametric. Parametric's not tough. Go to polar, push enter. See? Now push y equals. Look, it says R. Type -2 sine theta. The theta is where the x is at. Just push x and theta will come out. Don't push graph yet. You guys ready? Push no, don't push window. Go to the very left and make this look like a little go where it says line. If you have the old school, just push enter until you see this character. Until you see what character? This one right there with a little, like, kind of looks like a little key or a little hole, like that. See? And now look what happens. I'm going to push graph. Child, that doesn't look like a circle. That's because my window's not a square window. Push zoom and push square number 5. And look at that. It went too fast. Let me see if I can zoom in. 2. Look, that's a circle. And it is going too fast for me. So let me see if I can slow it down. Let's see if I can do the steps by 0.01. 0.01. Okay. Check it out. Ready? I'm going to push graph and look how it graphs. It starts at the origin, just like we did. Look at that. It's going to do it twice because I went at 0 to 2 pi. Isn't that cool? That could be anything, guys. That could be a meteor. We can go even slower. I can make the steps 0.001. Okay, check it out. Here's my meteor. And it's just traveling in space. Maybe that's too slow. Do you guys know how to tell the calculator to stop? You push enter and see how it's still, look at the top right hand corner, you still have this little thing moving like that. Push on and it breaks it. I'm talking about break as in like it stops the execution. Boop, see, stops. So now you can mess around with it and do all kinds of stuff. So let me make it speed up a little bit, 0.01. And look, here it is. There it is. That's a pretty good speed. Boom. And it actually does the whole revolution between 0 and pi. So when it says window, see that 6.28? That's 2 pi. If I just make it pi, look, it does the whole thing. 0, it starts there. Then right here I'm at pi over 2. And then right back to pi, and then boom, stops. Chop, why does it graph everything between 0 and pi? Because we're using sine x. And sine has all the values for sine, positive and, well, okay, we're not going to get into that because that might be too much. You guys might give you a headache, so I'm not going to talk about that. Are we okay so far? What do you guys think? Not bad, right? Okay, let's write some notes on how to tell what's always a circle. What's always a circle? So what's always a circle? I'm going to write it in this page. Well, if you have r equals something, r equals a number. What letter do you want me to use for number? A? If I have r equals a, that's it. Always a circle, no matter what. If you have r equals a cosine b theta, no, just say theta. R equals cosine theta or r equals a sine theta, those will always be a circle. For both of these, I'm going to write what both of them have in common. Diameter is absolute value of a. For the one on the left, the cosine one, I'm going to write the bullet here on the left. Center is parenthesis. This is symmetric on the x-axis, so the center is going to be a over 2, 0. And I guess I should have color-coded. Okay, so I'm going to write this one in blue to color-code it. And the one on the right the center is, comma, 0, comma, a over 2, because it's symmetric on the y-axis. So let me write that down here. Symmetric, the one on the left, the cosine, symmetric on, well, it's cosine, so what do you think it's going to be symmetric on? X-axis. The one on the right, the one with sine, is going to be symmetric on the y-axis. So anytime you have r equals a cosine theta, or r equals a sine theta, it's going to be a circle. Always, always, always. I know, guys, I know. This can be brutal. Are we okay? All right. Do you think we can handle this one here? Oh, should I go back? By the way, these are called limacons. Limacons. This is a rose. This is called a rose. This one, it has petals. That one looks like a circle. This one has an inner loop. This one has a pole. This one has no inner loop. And this is just a line. These are all called limacons. Cool? All right. Oh no, Chav. What about this one? Don't worry. We'll be fine. Before we do anything, I see a sign. So it's symmetric on the... You see this negative 2? Think of that. Think of this. Think of this as y equals negative 2 minus 5 sine x. That negative 2 is like a midline. That 5 is like an amplitude, right? So think of this like this. Here's negative 2. If I were just to graph it, the highest it goes, negative 2 plus 5, 3, and then the lowest it goes, 5, 6, 7, negative 7. Child, what are you doing? I am so confused. Remember how the first semester all we did was graph these equations with the midline and the amplitude and all that good stuff? What I want to know is, will this cross the x-axis or not? Will it? Will this graph right here, not the r equals, but the y equals negative 2 minus 5 sine x, will that cross the x-axis? What do you think? Yeah. You see this places where it crosses the x-axis, guys? That's what creates the loop. So it's going to be one of these. Chop, I don't understand. What's going on? I'm going to go slow. When you cross the... Should we just plot some points so you guys can see what's going on? Let's just plot some points between 0 and pi over 2. I'm going to plot some simple ones. And then we'll see. Theta r. 0, pi over 6, and let's just go right to pi over 2, and we're going to keep going from that. So if I plug in a 0, sine of 0 is 0. I know this is hard, guys. I know. I'm going to stop right now because this is super hard. Sine of 0 is 0. Negative 2 minus 0. Cool? Negative 2. So here's my first point. Remember that coordinate is negative 2 comma 0. So here's my 0 axis, and I go negative 2, so I'm right there. All right, next, pi over 6. Sine of pi over 6 is a half. Half of negative 5, so 2.5. Negative 2 minus 2.5, negative 4.5. So pi over 6, negative 4.5. So here's pi over 6, negative 4.5. 1, 2, 3, 4, 4.5. Pi over 2, negative 4.5, comma pi over 6. Pi over 2, sine is 1. Negative 2 minus 5, negative 7. So I'm down here. 1, 2, 3, 4, 5, 6, 7 points. Job, you went so fast. Say it again. I just plugged in a pi over 2 in here. and sine of pi over 2 is 1, and I just got negative 2 minus 5, which is negative 7. You know what I mean? Yeah. By the way, those points there are my order. It's the order. Next, what am I going to put next? I'm going to put pi. I didn't want it to be blue. Pi. At pi, sine of pi is 0. So I get negative 2 again. So pi and negative 2. So I'm right here now. Do you see what we're doing, guys? I'm going to use, what should I do now? I guess I'll do 5 pi over 6. No. I already said pi. So 7 pi over 6. I should have done 5 pi over 6, but oh well, that's okay. 1, 2, 3, 4. This is my fourth one. All right. 7 pi over 6. Sine of 7 pi over 6 is negative half. Negative times a negative is a positive. So negative 2 plus 2.5. What is that? 0.5? Did I do that right, guys? I mess up all the time, so check. 7 pi over 6. 1, 2, and then 0.5 right here. I think that's enough. Oh, no. I still need 3 pi over 2. 3 pi over 2. By the way, that's my 6th point. 1, 2, 3, 4. That's my 5th point. There should have been a 5th one, a 6th one, but that's fine. 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative times a negative is a positive. Negative 2 plus 5. 3, no? Okay. 3 pi over 2 and 3. 1, 2, 3 point. Okay, I think that's enough to get to see how this is going. You guys ready? So here it is. I'm going to sketch it in red. Between 1 and 3, when I'm in quadrant 3 over here, my radius is going to be increasing. So I go like this. Let's see. Like that. Now I'm approaching the number 4 here. Ooh, do I have a number? Let me make sure that at 3 pi over 2, that's correct. 3 pi over 2, negative, positive, negative 2 plus 5. Yeah, that's correct. I should have done something like at pi over 2, negative 7. That's correct. Okay. It should have done something like this. Where it should have been going right through the center there. My graph sucks, but I know, Goda. We'll finish right now. Are you okay? What's up? Because I plotted them, and I know it's measured on the y-axis, so it has to have the same order as whatever I started off from the beginning. So, I started here, I went to here, I went to here. It's measured on the y-axis, so I know that the next one's going to be somewhere here. I didn't plot that. And then I'm going to go here, and then I know that I'm going to have a pole somewhere between. I know I'm going to cross the x-axis, so this, I see that point right there, should have been like that. Already 0. And then when I cross this, my R gets larger, so I'm going to be like that. And then I get to here, and then I go back to that pole and I hit that. As a matter of fact, it's probably better if I do it with this. Let me do that. You're going to be doing so many that you're going to be able to identify it really quick. All right, let me just tell you guys the hack. You guys want to just know the hack? Okay. As soon as you see this, you already know it's going to have a loop. It must have a loop. Chav, why? How do you know it's going to have a loop? Because I crossed the x-axis. And this is what creates this part of that loop right there. And I know right now you're kind of like not seeing it, but because I'm not doing a good job of it. But I'm going to show you guys right now. Let me move to one that does not have one. That one has it. That one has pedals. Look at this one right here. Just look at it. If I were to say y equals negative 4 minus 3 cosine theta, this is like a midline. So this is like saying negative 4 is down here. This is my amplitude. It goes all the way to -1, and then 4, 5, 6, 7, all the way to -7. And if I were to graph, I know this is cosine, but I'm just going to just draw a generic sinusoid. Does that sinusoid touch the x-axis? No. So if I did not touch the x-axis, that means my r is never 0. So I'm never going to, so my polar graph is never going to touch the origin. So it's never going to have a loop. It's not going to have a butt. Sometimes they call it a butt. It's going to be something like this, where it has no loop. Does that make sense? I know. In a little bit, I'll show you a visual, and so you can see what's really happening. But I'm just not doing a very good job of that.
Why is that one different than the circle on the left?
Than this one?
No, the second one to the left.
Oh, that's a circle. This is a circle. This one has like a, see, it's squished, like a dimple. This one's it's a perfect circle. Like, it's a perfect circle. This one is not. Like, see, my radius, see, that says r. My radius varies depending on the theta. If I make cosine 0, my radius is -7. If I make cosine pi, my radius is -1. You see that? Okay. Here's the hack. Look how easy it is. Here's my hack, guys. No, focus real quick. Let's do the loop ones, because the loop ones are the easy ones. Go to this one right here. Don't worry, we're going to show you real quick. Here's the midline. Here's the amplitude. Do I cross the x-axis?
No.
Yes. Circle the loop. Chav, how is it going to look? I just care about my high and my low. The high, or I guess my max and my min. Max. Well, let's see. My max, I see -2 plus -2 plus 4, so that's 2, and that happens at pi over 2. So that's going to be 2 comma pi over 2. Did everyone see how I did that? Yeah, because sine has a max at pi over 2 and a min at 3 pi over 2, my 1 and -1. So my min, -2 minus 4, what's that? -6, right? And that happens at theta equals 3 pi over 2. So -6 comma 3 pi over 2. Here's what you're going to do. You're going to come over here and you're going to graph this, pi over 2 comma 2. So pi over 2 comma 2, 1, 2 points. And then you're going to go 3 pi over 2 comma -6. So 3 pi over 2, -6. 1, 2, 3, 4, 5, 6. Boom. And this is going to be your small loop. So it's going to look something like that. And then I'm going to have my big loop. It's not very good. I know, I just sketched it. I did a really crappy job of it. If you, it should have gone through right here and right here. So it should have gone like, should have looked something like that. But I did a really bad job. Let me log in and so you guys can see what I'm talking about. So look, it's going to all make sense right now. You don't have to be a perfect. By the way, you have a calculator, by the way. Let's type that one in. Give me the one that I just told you guys about. -2 plus 4. Find theta. Check it out. Check this out. Look, it starts right there. Wow. It's actually going to go above that. Oh, I just went 0 to pi. Let me go 0 to 2 pi. Window 2 pi right here. 2 pi. Graph. All right. I'll zoom out right now. So here's 0 to pi right there, and then it keeps going up. And eventually you're going to see it come down here. And let me zoom out. And don't worry, guys. It's all going to make sense right now. Okay, there we go. I know. All right, check it out. Let me go to Delta, and let me show you this super magic. We used to do this so cumbersome. We used to plot so many points, it would take forever. But now we can just... Look, guys. I'm going to uncheck. I'm going to put pre-count. We'll put polar. And that's how it looks on my end. I'm going to go to polar graphing. Okay. And then don't worry, I'm going to show you something. Look, r equals -2. That's always just going to be a what? Circle. Circle. And then just go to 2. Submit. That one's not anything crazy. All right, new problem. All right, look at this. -2 plus 2. You touch the x-axis. If I were to say this is y equals -2 plus 2 sine x, but does it cross the x-axis? So this is just going to hit the, that's what it says, hits pole. It's just going to touch the x-axis but not cross it. So it's this one. Boom. Do you see that? And now look, it's a sine theta. So Chav, how do I do it? Well, sine theta is symmetric on the y-axis. Yes or no? So all you care about is that pi over 2 and 3 pi over 2. So I'm going to plot the pi. One of them is going to be a 0. So sine of pi over 2 is 1. Yes or no? -2 plus 2 is 0. So at pi over 2, it's a 0. That's it at the origin. So now let's do the 3 pi over 2. Sine of 3 pi over 2 is -1. -1 times 2 is -2. And -2 minus 2? No. -4. So what am I going to plot? 3 pi over 2, comma, -4. So go to 3 pi over 2. That's the negative y-axis. And -4, I go in reverse. 1, 2, 3, 4. I'm right here. So take this little point and you just drag it. See? You just drag it right there. And it's going right through the pole, the origin. There it is. And there it is. And I just put submit. Check it out. And voila. And look, here's what I wanted to show you guys. This is what is so magical. Look at this. Can everyone see this? Look, I'm going to change my theta from 0 to 2 pi. Look, see the one in the graph is just y equals -2 plus 2 sine theta. And look what happens when you touch the x-axis. Bam, I'm right at the origin. See? Because the r is 0. And then look, you don't cross it. So that's what creates, see? And then bam, right there. That's at 3 pi over 2. See? At 3 pi over 2, it's -4. So 3 pi over 2 and then go -4 in reverse. So you're right there. And then look. Isn't that cool? Don't worry, we're going to do a whole bunch. Look. Okay, we're not ready for that one yet, but we will. We will in a little bit. Look at this one. The midline is 2 and the amplitude is 3. Am I going to cross the x-axis? Yes. So this one's going to have a loop. Do you guys see that or no? So you click on the inner loop. It's a limicon, inner loop. And now check it out. How is it going to look? It's a sine. I just care about my min and my max. Pi over 2. Sine of pi over 2 is 1. What is 2 minus 3? Positive or negative? So pi over 2, -1. Here's pi over 2, -1. I go to reverse. Get the little guy. That's the little guy. That's my little pole. And then -1 right there. Hold on. Now let's do the 3 pi over 2. Sine of 3 pi over 2 is -1. Negative times a negative is a positive. What is 2 plus 3? 5. So here I am at the negative y-axis, and I'm going to go 5. 1, 2, 3, 4, 5. Do you guys see what we did? And I'll watch. Check it out. Submit. And look. Don't leave yet. Well, you can't leave because you're. All right. Look at this. I'm going to zoom out. Look at this, guys. Boom. And look, when I cross the x-axis, here's what creates my loop. Look, here's what I was talking about. Boom. There it is. That's what created my loop. And then when you're touching the x-axis there, well, my r is back to 0. So that's what created that loop there, guys. And now look. Woo. Isn't that cool? Are you not entertained? What about this one? Tell me, do they have a loop or does it not have a loop? No loop because it does not cross the x-axis, but does it have a pole? Yes, so it's going to look like this one. See? Now this one's cosine, so instead of being symmetric with the y-axis, it's going to be symmetric with the x. So now we care about 0 and pi. So cosine of 0. Cosine of 0 is 1. 1 times 4 is 4, and 4 plus 4 is 8. So I'm going to graph 8, 0. So here it is, 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I got to go all the way over there. And I guess I don't have to worry about the pi one because that one will be the 0, 1, pi 0. I'm back at the origin. So there it is. And I submit. Is it symmetric with the x-axis? Yes, it is. Submit. See, there's an art to this. There's a little science to this. It's not that bad, guys. You can try to do this without graph. Try to do this without a calculator. Try. You can use your calculator to verify, but try to do it without a calculator. Now, you guys ready for something like, okay, use your context clues. Is there any R here? It just says theta equals pi over 3. That means my theta, I'm always pi over 3. Always pi over 3. What am I going to look like from all these right here? It's just going to be a line at pi over 3. Pi over 3 is, let's see, this one was pi over 12, pi over 6, pi over 4, pi over 3. So I just go to boop, pi over 3. And I just go submit. And voila. All right, let's see if we can go to, look at this. What is this? What did I tell you this was? A circle with a diameter of 3, and my center is going to be whatever this is divided by 2, 0, right? So I push circle, and okay, there it is, highlighted. And then what's 3 divided by 2? 1.5. So I go to 1.5, 0. So here it is. Here's my center, and I go to 1.5, 0, about right there. And then I make my diameter 3. Okay, so I need to move it. 1, 2, 3. So then move it more to the right. Does that look like 1.5? It's not perfect, but let's see if it takes it right here. Yeah, it took it. See? And you can see right here what's happening. What do you guys think? Okay, I think now we're ready for, what's up? Well, the diameter is 3. So the center? Well, if the diameter is 3, that means my radius is 1.5, and since it's symmetric to the x-axis, I just move it over. You know what I mean? Yeah, don't worry, we'll do more if we have to. Is this one going to have a loop? I don't know. It's not going to have a loop. Look, -5, and you see how I'll never cross the x-axis? I won't even touch the x-axis. So that means it's a limicon with no inner loop. It kind of looks like a circle, but when I push it, you're going to see it has kind of like dimples. So check it out. There it is. And because it's cosine, I care about the two extremes at 0 and at pi. What's cosine? It's symmetrical with what axis? The x. What's cosine of 0? Cosine of 0, Volpert. Cosine of 0, 1. 1 times 2. -5 plus 2. -3. So you're going to go 0, -3. Go backwards. So it's going to be over here. 1, 2, 3. There it is. Now, right now it looks like a circle, but it's not. Now I'm going to do the other extreme, the pi. Cosine of pi. -1. -1 times 2. -5 minus 2. So pi -7. Pi is the negative x-axis. -7. I go in reverse. So I'm over here. 1, 2, 3, 4, 5, 6, 7. Oh, I have to say 6, 7. All right, there it is. See, it's like kind of squish over here. So it's not a circle, guys. It's not a circle. Submit, and boom. Look, and it is symmetric on the x-axis, and then you can mess around with this and be like, oh, I'm getting it now. Boom. See? What do you guys think? Okay, check it out. Now, let's do some good ones that we were talking about. That's a circle. Okay, look at this. Okay, well, you see that 3 theta? That 3 theta means I'm going to have a rose. It's because if it would have been a 3 cosine theta, I had a circle. But as soon as you introduce a coefficient in front of that theta, you're going to have a rose. If it's an odd number, that's how many roses you're going to have in front of the theta. If it's an even number, that's how many roses, how many petals you're going to have. If it's an even number, you double it for the number of petals. So I'm going to click rose. And then what is that? Is that number in front of the theta an odd or an even? Odd. So that means I'm going to have how many petals? 3. So you leave it alone. It's cosine. I'm going to be symmetric on the x-axis. Choose the simplest one, and they'll do it for you. Look, there's already 3 petals. So here's what I'm going to do. I'm going to choose theta equals 0. What's cosine of 0? 1. 1 times 3? 3. So I'm going to go to 0, 3. So here it is. This is a 0 radian. And 3. 1, 2, 3. It does it for me. And there it is. Am I symmetric on the x-axis? Yeah, I am. And I'll push submit. And look at that. And look, check it out. Check it out real quick. if you move this guy around, look, you can just go all the way to pi and you can already see what's happening. Bam, bam. See, isn't that cool? Don't worry, let's do some more, and that way we can get you guys warmed up. Look at this, -3 cosine 5 theta. Is that an odd or an even number? What type of shape, by the way, do I get? It's a rose. If it looks like this, it's a rose. If that 5 would not have been there, it would have been a circle. That 5 turns it into a rose, and now that 5, it's an odd number, so how many petals am I going to have? 5. So there it is, 5. And again, it's a cosine, so it's symmetric on the x. Just use the easiest one. Use the 0. Cosine of 0 is 1, and 1 times -3? -3. So I'm going to go 0, -3. So go in reverse. 1, 2, 3. -3. And there it is. Is that symmetric on the x-axis? It is. Submit. And then look. Voila. Is this getting more and more fun? Yeah. Let's do a sign that does not have a... let's keep going. No, that's a circle. Okay, this is an even number. I like that. What shape is this? Rose? You see that 2 there? Because it's a 2, because it's even, I'm going to have how many petals? 4. You double it. 4. And it's a sign. It's supposed to be symmetric on the y. So the sign ones are a little difficult, but it's not even that much. You want to think of how to get this to be a pi over 2, the argument. So, you see how I have a 2 in the front? I'm going to choose pi over 4. Chop, why are you choosing pi over 4? 2 times pi over 4 will give me pi over 2. Do you guys see that? So that's why I'm going to have a rose that's the biggest possible rose. Okay, Chop, what are you doing again? I'm trying to get my argument to be a pi over 2 so I can get sign of that argument to be a 1. So I chose pi over 4. Yeah or nay? So sine of pi over 2 is 1, and 1 times -4 is? -4. So I'm going to go to pi over 4. Here's pi over 4. 1, 2, 3. It's this one right here. And I'm going to go in reverse to -4. So I'm going to come over here. So let's see. 1, 2, 3. -1, -2, -3, -4. Right there. See? And there it is. Is this symmetric? Well, it also happens to be, by chance, symmetric on the x-axis because it was an even petals. But it is. Is it symmetric on the y-axis? It is. So look, submit. And look at that. Don't worry, guys. We'll do one that is not a pretty number, like something like pi over 10 or something. Let's see. That's just a line. Look, we're doing as many as we can. We've already covered all of them pretty much. See? There's nothing that they can throw at you. Look at this. I love it. I love it because it's not a perfect right on the grid. Okay, you see that 5 in there? So I'm obviously going to have a rose, right? I'm going to pick rose. And remember what I said. I want this argument to be a pi over 2 because sine of pi over 2 is 1. Yay or nay? So I'm going to choose pi over 10. But Chop, these grids are not in pi over 2. These grids are in pi over 12. Is pi over 10 bigger or smaller than pi over 12? It's bigger, no? Do you guys know what I'm trying to say? No? Okay, let me slow down. Okay, first, how many petals do I have? This says 5, so I'm going to have how many petals? 5. Okay, and remember that I want this that I'm highlighting to be a 1. So what can I insert into theta that I'll make sine of 5 theta equal to 1? Pi over... Yeah, what did you say?
5?
No, not 5. Pi over 10. 5 times pi over 10 is pi over 2. Yes or no? But Chavez, ready, Lopez Jimenez? But Chavez, this is pi over 12, and pi over 10 is bigger than pi over 12. That's okay. It doesn't have to be perfect. So look, what was it? -3. So I'm going to go to pi over 12, well, pi over 10, which is a little bit past this, because pi over 10 is a bigger number than pi over 12. Everyone agree? So I'm going to be right here, like a little bit below the pi over 12, and I'm going to count to negative what? -3. So look, -1, -2, -3. I'm going to say we're like right here. Let's see if it takes it. Does that look symmetric on the y-axis? Maybe I'm a little off. Right there. Let's see if it takes it. Submit. Look at that. You don't have to be perfect, guys. You don't have to be perfect. Do you guys see what we're doing? All right. I think we've covered everything. Hold on. I hope it doesn't make me start from the beginning. Let me do a new problem that doesn't take so long. That doesn't go through 0. That goes through 0. Okay, look at this. Let's start it again. Sine of 0, 0. Sine of pi over 6, 1/2. Sine of pi over 4, square root 2 over 2. Sine of pi over 3, square root 3 over 2. Sine of pi over 2, 1. I'm multiplying by 5. 0 times 5. 0 times 0.5. 2.5 or 1/2. 5 times square root of 2 over 2. I'm just going to put, let's see if it takes it. 5 square root 2 over 2. Yeah, I took it. 5 times square root 3 over 2. So I'm going to write the same thing. 5 square root 3 over 2. And it took it. 5 times 1. 5. All right, now I'm just adding 1 to it. So I'm just going to move up by 1. 1. 3.5. 4.54. Oh, put a comma instead of a decimal. 5.33 and 6. Okay, there it is. I'm just plotting. Now I'm good because I don't have any zeros. That's when you mess up right there. 0, 1. So look, I'm at 0. I'm at 1. So here it is. 0, 1 point. Next one, pi over 6, comma, what's this? 2, 4, 6, 3.5. So pi over 6, 3.5. 1, 2, 3, 3.5. I know, we're almost done, guys. Pi over 4, 4.54. So pi over 4, here it is. 1, 2, 3, 4.54 right there. And then pi over 3, 5.33. Pi over 3, 1, 2, 3, 4, 5.33. So like right there. And then pi over 2, 6. 1, 2, 3, 4, 5, 6. Point. And there it is. And then I'm going to push try. And hold on. My laptop. Oh, there it is. Now I have a pencil. Do you see how you have a pencil? Start in this order. So the number one mistake is sometimes you guys go like that. Start in this order. And look, I'm going to draw it ugly on purpose. It doesn't care. Let me start again. It doesn't care. Make sure you touch them, though. Look how ugly it is. And let's see if it takes it. It's going to take it. See? Great. And look how ugly it is. You correctly calculated, plotted, and sketched the graph 0 to pi over 2. Next, don't worry. You're already done. You're just going to be pushing a little slider. See, they graph a whole bunch of points for you. And then you just push a little slider so you can see the visual so you can start to understand it. So look, I'm going to push my slider. You don't have to do any of the sound effects. And then zoom. So there it is. And then you're like, oh, okay, submit. And then are you sure? Yeah, of course. And then there it is. And it gives you that. So what do you guys think? I know it was a lot, but do we feel like we kind of understood what's going on? All right, guys, that's it. Let's make an attempt. All right. Thank you guys for being a good sport.